Hey there, everybody. So in this video, we are going to talk about the volume of prisms, because I told you in the last video that we would be talking about three-dimensional solids, and here they are. So what is a prism? So a prism is a solid. A solid means 3 dimensions. So when I use the word solid, I am talking about a shape that is 3-dimensional. It'll have 2 parallel and congruent faces called bases. The other faces are always going to be parallelograms, and they're usually rectangles. We always name our prisms by its base. Alrighty, so our bases, that's the most important part of this prism. So we're going to ask ourselves, all right, here's my base. So the base is the side that's not a parallelogram. So this triangle in the front is a base. There we go. Oh, I'm not seeing it. Boom. And this triangle in the back is the other base. There's always 2 bases. There are always 2 bases. So in the front, we have a base, and in the back, we have a base. Notice again, base doesn't mean top and bottom. And then we have our parallelograms. The sides, for lack of a better word, are our faces. So because this is a triangular prism, these rectangles are the faces. I'm not going to color them in because then the base will disappear. But these rectangles are the faces, and there are 3 faces. Okay? As I said earlier, this is a triangular prism. Boom. So it's a triangular prism. This shape, notice every shape on it is a square or a rectangle. So it doesn't matter which one is a base. It doesn't matter which of the parts are the base. So just for fun, let's make the bottom and the top my bases. So we got bottom. There we go. So these 2 bases are rectangles. So this is a rectangular prism. They're named by the bases. And the bases are always congruent to each other. So this front triangle is congruent to the back triangle. The top rectangle is congruent to the bottom rectangle. Now we just don't need triangles and rectangles. Here we go. This shape right here. Notice the base, the non-rectangle, is this hexagon right here. And the hexagon in the back. There's always 2. There are always 2 bases, and the bases are always congruent to each other. Base and base. So this is a hexagonal prism. And it's a prism because it's the same. There are the same number of hexagons going all the way up. And then this last one, we can also do the base with circles right here. See, we got a circle on the bottom. The base is a circle. The base on top is also a circle. This one only has one face. It's one giant rectangle that wraps around this whole can. And this, you can either call this a circular prism Nobody will, but it could be classified as a circular prism. But the more common and the better name is cylinder. The ones that look like soup cans or soda cans, those are cylinders. Now, cylinders and all prisms have volume. Volume is the amount of three-dimensional space that this thing holds or occupies. Volume is always going to be measured in cubic units. So volume is the amount of stuff on the inside of this solid. How much does this solid hold? Well, should have used a broader tip highlighter. That's the volume. The volume is the amount of space on the inside. And today we're going to be figuring out how to calculate that amount of space. We are going to use the formula for all prisms. This is for all prisms, where we are going to do big B times little h, where V is my volume, big B is the area of the prism in square units, and h, this little h, stands for height of the prism in units. So we're going to do big B, or big V, big B, h. H is called the height of the prism, the distance between the bases. So if I was to look at this shape here, I would need to find the volume. I would need to find the area of one prism, or one hexagon. That's a hexagon. And I would find the length of that height. So what I would calculate is I would calculate big B, and I would calculate h, the height of the prism. Height of the prism is the distance between the bases. So for me to say volume for this, I would say volume. And then big B in orange, for all regular polygons, and that hexagon is, I would use this formula right here, where h is the height of my prism, and 1/2 times perimeter times apothem is the area of that hexagon. We learned that in the last video. And volume would be the amount of space on the inside of the shape. For my prism, I keep saying prism. They're all prisms. Inside this cylinder, I would say here's the base. There's big B. There's H. So here's big B. Here's H. So to find volume, the B is a circle. So the area of a circle is pi r squared times the height of the cylinder. So pi r squared gives me big B. H is the distance between the circles. All right? So that's how we would find the volume of a hexagonal prism and of a cylinder. Okay, so the steps: identify your solid. Is it a triangular prism? Is it a rectangular prism? What type of prism is it? Identify the shape of the base. That goes back with this. What type of prism is it? Write our formula. Notice when I did it, I wrote down these formulas. Write down the formula. Find the area of the base, H or R and H for cylinders. Plug in our given parts in our diagram. Highlight, highlight, highlight. I can't stress that enough. And then solve for what's ever being asked for. All right? So we're going to get started here in a moment. So if you got any questions, make sure you ask.